Welcome to Eduonics. This is Kaushik. I am your instructor for this tutorial on Spring Framework. Today, in the section 4, we will be discussing about the Spring Framework, its overview, different components, how it works, and some of the implementation details. Before we go forward, let's have a look what we have in the content. First, we will be talking about the overview about Spring Framework. We will not discuss about the traditional definition of Spring. Rather, we'll be talking about something different, which will give more insight about the Spring framework, how it works, what it actually does. The second point is J2E pain points. Basically, Spring framework has been evolved to solve existing J2E pain points. So we will be having an in-depth understanding of the existing J2E pain points. And then we will check about the Spring benefits, how it works and how it can help to overcome those J2E pain points. Then we will have a module where we will be talking about different Spring modules like Spring Core Container, Spring Inversion of Control, Spring AOP, Spring MVC, the data access layer of Spring, transaction management, remote access, how it works, then convention over configuration, then how authentication and authorization is performed in Spring, Spring Batch, Spring Integration, and Spring Testing Framework. Lastly, we will be having a QA session to validate your knowledge, what you have learned during this session. First, let's have a look at the overview of Spring. In a traditional way, Spring is defined as a lightweight open source application development framework widely used for Java-based applications. Let's keep this definition aside and talk about what Spring actually does, why it is popular, what are the inner points that should be known to a Spring developer to understand it properly. The first point is Spring provides comprehensive configuration and programming model for Java-based application development. What does it mean? It means the programming model supported by Spring covers all type of Java-based applications, be it a traditional standalone application, be it an enterprise application, be it a product, or be it a web-based application. It covers all these types under its umbrella. The second point is most important point, which is a POJO-based promotion, POJO-based programming model, the promotion of POJO-based programming model. POJO is the simplest form of a Java object. When a developer starts working with Java, he writes his first object as a plain old Java object. And these POJOs are the building blocks of a Spring framework. All the beans are simple POJO plain old Java objects. So the learning curve is very short. Anybody can write up simple plain old Java objects and make it work as a Spring Beans. The third point is it supports all type of deployment platform, be it a web server, be it an application server, be it a different environment altogether. The fourth point is it provides infrastructural support at the application level. Just mind the word application level. It has a significance, right? Because the Spring framework supports or it provides the infrastructural facilities at the application level, which supports applications. Or rather, you can say that when you are developing an application, whatever infrastructure you need, Spring provides that for you. So you don't need to worry about the infrastructural side. You can concentrate on your application development only. Now, before we talk about the benefits of Spring Framework, let's have a look at the J2E pain points that is there with the existing applications, existing enterprise applications. The first and the most important point is plumbing code, excessive amounts of plumbing code. What does it mean? It means we used to write a lot of code, Java code, which were never used in the application, following the traditional J2E technologies. And before the arrival of Spring, this type of excessive codes makes the application worse, beyond your control, and at a certain point of time, you can't maintain it at all. The second point is inappropriate distributed object model. What does it mean? Any enterprise application is distributed in nature. It runs into different environment, different deployment. They interact with each other, they communicate with each other, they work with each other. But with traditional EJB model or any other traditional technologies, the distributed model that is created is totally inappropriate, and at some point in time it goes beyond your control. You can't control that distributed environment where you're deploying your application based on the traditional J2E technologies. The third and the fourth point are on the EJB model itself. EJB model is a very complex model which didn't work as it was expected to be. For example, the entity bean is a total failure. It reduces the performance. The objective of entity bean was to persist data as an object and facilitate the object creation, its persistence, avoiding the traditional raw code and insert the raw data into the database. But what actually it does? It loads the code. It inputs a lot of code which is not necessary, which our developers should not worry about, should not write about. So a lot of effort is gone into this particular development, creation of beans, rather than writing the business logic. So overall, the EJB model, particularly the entity bean, is a failure. It doesn't work as it was expected to work. The last point is the difficulty in unit testing. Your enterprise application is successful when you have the most testing coverage. But using a EJB model, it's very difficult to test your code. The unit testing is a pain point in the traditional J2E technologies. Now let's have a look how Spring comes here, how Spring helps to overcome those technologies. The first point, as we have repeatedly mentioned, that it's an open source, lightweight, loosely coupled framework, which is easily maintainable, extendable, and you can enhance it. It never goes beyond your control. The second point is Spring helps to reduce unnecessary and duplicate code. That's we talked about the plumbing of excessive code. In Spring, you do not write excessive code. The supporting environment is provided by the Spring itself. The third point is Spring takes care of infrastructural issues at an application level, so the developers can concentrate on business itself, which is the most critical part for any application. A developer, an architect, or any tech lead should be concentrating on the business logic rather than the supporting infrastructures. So that's what Spring does. Spring provides declarative programming model. What does it mean? Means your programming model can be made declarative. You can put the parameter and values at a declarative level rather than putting some hard coding or some properties file. The last point is it provides options to integrate with other J2E tools. It means Spring comes with all the components, all the features. But on top of it, your application might need some other J2E tools, which are very important, which are more efficient for your application. Then Spring gives you the opportunity to integrate with the other J2E tools, the logging tool, the unit testing tool. For each and every tool, Spring has its points to interact, points to integrate. So that's the biggest facility of Spring to support the existing J2E technologies. So you can use Spring as it is with the other technologies. Now, Spring overall provides all the supporting uh, features for developing an enterprise application. So You don't need to worry about the other aspects, other enterprise level components. The basic feature, as we have discussed, is the Spring EOP and Spring DI, as you have defined here. So these concepts are the backbone of Spring. It provides the support of inversion of control and the aspects-oriented programming into Spring features in the Spring model, which is very helpful to develop any kind of enterprise application. The Spring MVC is the another part which is very important to understand and to work with the traditional MVC model, which has better features than traditional start-based MVC model. It provides data access layer, it provides transaction management, it provides remote access. And the most important part is Spring Core Container. The DI and AOP are a part of Spring Core Container. And in the section we have understood like the test framework that we have just discussed, like how Spring works, how Spring helps in unit testing. It provides the authentication and authorization. For example, your enterprise application needs to be secure, so Spring has a feature for it. You have a security model which is available with Spring, which can be used to secure your application. Spring Batch is very important to run any batch job, which we used to run in an enterprise application. Like we need to run some work on the background of an application. So there we need to configure the Spring Batch, which is very efficient. And the other axis is the transaction management. Spring provides very efficient support for transaction management. So that can be used widely. The data access layer, which we have talked about, and which is very efficient compared to the entity beans that we have just discussed, like entity beans are a load to the application. It doesn't perform well. It doesn't give performance boost, but Spring Data Access Layer, Spring ORM, Spring JDBC template are very efficient and very lightweight to access the data. So overall, Spring provides all the features that needs to be there in our application development to work properly, right? So this is the benefit of Spring Framework, what we talked about, the different features, how it works, how it overcomes the J2E pain points, basically the excessive plumbing of code using EGB model, overcoming the unit testing difficulties. So those areas are very important where Spring plays an important role and it covers all those areas. That's why Spring is so popular nowadays. It's used in all the area. The other important point which I should mention here is that in a Spring it consists of almost 22 modules, 22 features, 22 components, but you can use as many components as you want. You can reduce the number of components, you can choose the number of components which is required for your application and forget about the other components. You can integrate with other J2E technologies. You can integrate with other J2E features and taking care of those things within Spring Framework, like the Spring Hibernate. It has a support for Hibernate. It has a support for iBatis. Those are typical ORM tools, so you can have those things in place and still you can work on the Spring Framework. Spring Boot is another important feature which we'll be covering in our next section, which reduces more boilerplate codes. Even you don't need to wear the bins manually, where the bins in a configuration file which we used to do in traditional application. That is also removed with the Spring Boot applications. So those features will be coming in our next sections. And what we will do in our next section, we will take each and every component of Spring, like Spring AOP, Spring IOC, Spring MVC, Spring Boot, and all the other features like transaction management, Spring Batch, Spring Integration Framework, and write some code to test the application to understand how it works. In the last section, we have some QA, which you just need to understand how it works, and it gives you a understanding what you have learned throughout this section. So hope you have enjoyed this session, and in the next session we'll be taking each and every features of Spring Framework, and we will be writing some practical code examples to understand your clearing. to understand the concepts that you have learned.